Everyone, it's Miss K doing a video on trig and Pythagoras. Lots of formulas linked to this topic, all concerning triangles. So this one is dedicated to my year 11s who have requested for this. So a short revision video on everything we touched on in trigonometry and Pythagoras. Okay, so what I've put together is sort of a guideline on how you could make a revision card for this topic. I've got a lot on here, as you see, so it might be better to condense everything down on an A3 sheet of paper, so you can kind of mind map what you would apply to what. Now, as you notice on this sheet, we have all right-angled triangles. Okay, even this one's a right-angled triangle, even though it's not stated. Now, there are two things that you could actually apply to right-angled triangles. You can apply Pythagoras' theorem, or you can apply basic SOHCAHTOA in relation to finding angles and sides. So I think the one thing you need to be careful of is when you apply Pythagoras and when you apply your basic trig. So let's just take a look at these two questions here. Now, as they just contain a right angle, you can apply Pythagoras' theorem, whereas these questions, as you notice, it's not just a right angle stated, but it's also an angle. Now this angle is called your reference angle. This is 30 degrees in this question, it's 50 degrees. If there is a presence of a reference angle, then you're going to apply trig. But if there is no presence of a reference angle, then you are highly likely to apply Pythagoras. Okay, let's take a look at this question over here. There's no presence of a reference angle, so I'm going to go straight forward and apply Pythagoras' theorem. Now, what I need to do in order to find out the longest side, which is called the hypotenuse, which is marked as x for this question, is that I'm going to square both sides. 24 squared, add them up, and then that answer I'm going to square root it. So that will give me 601, and when I actually square root it, I should get 24.5 to 1 dp. Okay, now just moving over here, this arrow is also green, so it means I'm going to apply Pythagoras' theorem. How can I just double check? Is there any reference angles? No, only the right angle is stated. Now this question is slightly different from the other one because when they give you the longest side, which is the hypotenuse, in other words, you're trying to find out one of the shorter sides, you need to slightly change this formula. So you'll take your longer side, your biggest measurement first, 15 squared, and also square the 7, but this time you're going to subtract the two answers, and that gives me 176. I'm going to square root it so I can just get a, and that will give me 13.2 to 1 decimal place. Okay, so moving now downwards, I'm looking at these triangles which are marked with this dark red. We need to apply the trig ratios. So there's SOHCAHTOA. Remember, in the exam you have to remember this. They're not going to give you this in the exam. So just remember how to lay out the triangles in case you make mistakes. So let's just take a look at this one. Okay, so the first thing I need to do to apply basic trig to a right angle triangle, I need to mark my sides. Now at the moment, they tell us that this is 25 feet, and so we're going to label it H. H stands for the hypotenuse. Now there's a H there, but it doesn't mean it's the hypotenuse. You now need to label it correctly. We're going to label it as O because it's opposite our reference angle. So any side that is opposite to the reference angle is always called our opposite. Now this angle, this side is actually called the adjacent because it's touching our reference angle, but I'm not going to mark it off. Now the reason why I'm not going to mark it off, because there's no indication of what it is or if we have to work it out because this is left empty. So that means I need to look within my trig triangles over here, which one has an O and a H. Now it's the sine that has the O and the H, so what I'm going to do, the sine is at the bottom and so is the hypotenuse. So that means the two are multiplying each other to give me O. So I have sine 65 multiplied by my hypotenuse, which we've already can see is 25. Now if you have the Casio calculators, they will have a bracket around that opens up so you can enter your angle. Just make sure you close your bracket and multiply it by 25 then after. So that answer is 22.7. So 22.7 feet is the length of H. Remembering we were trying to find out O. Okay, so now let's move on to this triangle over here. The first thing is we're going to have to mark off. Again, the hypotenuse is not referenced in this question. We're not having to find it out, nor are we given information about it, so I can ignore it. This H is opposite to the reference angle, which is 30 here, and A is our adjacent, so the adjacent always is the one that is touching the reference angle. That is not the hypotenuse. So O and A, can you think which triangle I need? Yes, I need TOA. So make sure you do write out this box beforehand before you start doing a trig question, so you can just pick and choose which is the right one. Okay, so O and H, we're trying to find O. O is the one that's placed on top. Tan is at the bottom, and so is adjacent. That means these two are going to multiply each other to give me the O. Okay, so I'm going to do tan 30 multiplied by 25, and that will give us the answer to O. Just remember to put brackets around. So tan 30 multiplied by 25 equals to 14.4. So this is 14.4. Okay, brilliant. Now let's move on to the next one. For tilted triangles, I did notice some students get slightly confused with this. Just remember 8 is not the adjacent, it is the hypotenuse. Okay, how do you spot the hypotenuse? It's always opposite the right angle triangle. Sometimes it's not really obvious by eye that this is the longest side with certain questions. So this way of looking for the hypotenuse is quite good, that it's opposite the right angle. So I've got H. Y is the one touching on the reference angle, making that the adjacent. So A and H is using cos. So I do cos 50 at the bottom, multiply by H, which is 8. So cos 50 multiplied by 8 will give me the answer. So let's just take the calculator and do it, and you do it too. So close bracket, multiplied by 8 will give us 5.14, but we're just going to write that as 5.1. So A is equal to 5.1. 5.1. Okay, so now that covers the right angle triangles, but what happens if you are then given the two following questions below? Well, so take a look. There are no angles there, but however they mark off theta, meaning there is a reference angle. So if there is a reference angle, that means I still need to stick to using the SOHCAHTOA trig ratios over here. So that's what I'm going to start doing and applying in my formula. So okay, so I've got 5, which is the adjacent, and I've got the opposite, which is 8. So that means I need to use TOA. So I have TOA there. Now T stands for tan of the angle, and A is 5 at this point, and O is the one with and O is 8. Now as we're trying to find out the angle, I'm going to take my two known values and divide them, because the A is under the O. I'm going to do 8 over 5, and that's going to equal to the tan of the unknown angle. Now if I want to just get the angle on its own, I would have to take tan to the other side, but this time I'm going to have to press shift on the calculator. By pressing shift, your calculator will show tan to the power of this -1. So that is the inverse of tan. So by moving tan to the other side, you have to do the inverse operation. So inverse tan 8 divided by 5. You can also do it on your calculator to check. We have a degree of 57.99, which if we had to round to 1 dp, that would give us 58 degrees. So this is 58 degrees to 1 dp. Okay, let's try this question then. Also, it's where I need to try and find the angle. So remember, if I'm trying to find the angle, I'm going to need to press shift, and that's a very important thing that you may want to also write down in your revision card. So this is the hypotenuse, this is the adjacent, and so we are sticking to cos. We're looking at cos here. So let's just look at the positions of where these are in the formula. So cos theta is equal to 12 over 13. Theta equals to cos -1, because you're going to press shift cos, and that's going to be over 13. Okay, so let's do that. We're going to go shift cos 12 divided by 13, and that's 22.6 degrees. So 22.6 degrees. Okay, so that was a review of all the triangles that are right angle triangles that you could apply Pythagoras and Trig. If we continue the video, what you'll see now is what happens in the case of non-right angle triangles. So for example, these two. Well, if it's a non-right angle, you're going to apply the sine rule or the cosine rule. So this is where it gets a bit harder. So we're entering now the next level, the next grade, the higher grade. Okay, now there are two versions of the sine rule. You normally have also a third part, but you don't really need to look at that. You just need to know two parts of it. So there's two versions of it. One where the angles are at top, and one where the sides are at top. So which one do I use for what question? Okay, let's have a look at this first question. Now, when using the sine rule, you can only use it when you have a match. So what do I mean by match? In order to get a match, you have a known angle, which is 60, for example, and opposite that angle is 7. Now, both of these are known in the problem. So therefore, you're going to use the sine rule. Okay, so have you got a match? Have you got an angle on a side? Yes, you do for this question, so you're going to use the sine rule. But which version of the formula are you going to start to use? Now, as you see, we're trying to find out a side. Now, if you're trying to find out a side, then you want your sides on top, so I'm going to pick this one. Okay, now, let's take a look at how we'd answer this. Now, your unknown, which is x, is the one that gets placed on top. Opposite the x, the angle that corresponds to it, is 80. So always next to the angle you want to write sine. Now that is equal to this side, which is 7, over sine 60. Now you need to get x on its own, so you're going to take sine 80 and bring it to the other side. As it's dividing on this side, by bringing it over, the inverse happens, and you get multiplied by 80. So let's do that on the calculator. So 7 divided by sine of 60, make sure you close your bracket, then take that answer and press multiply sine 80. Okay, you should get 7.96. So the answer to this is 7.96 to 1 dp. That would just move, the 6 would move the 9 up to an 8. Okay, so depending on what the examiner's asked you. Now let's have a look at this question. First, inspect. Are we going to use the sine rule or the cosine rule? How do we inspect? We check if there is a match. So I have a side here, and there's an angle that corresponds, and I know that I know what those values are. So yes, I use the sine rule. As you can guess, I'm going to use this version of the sine rule now. How do I know that? Because I'm now aiming to find m. M is an angle. Okay, so if m is an angle, my unknown, which is sine m, is going to be at the top. What corresponds to sine m is 8. That's going to be now at the bottom. I know sine 75, and that's going to be over 10. In order for me to calculate this, I'm going to take this 8 to the other side and multiply it. So I'm just left with sine m. Now to get m on its own, I would take now sine to the other side and move over. So what do I press? Shift sine. Now remember, if you're finding out an angle, you always need to press shift. So you've got shift sine, where you have this symbol appears, the answer, which is everything that you worked out before, that will get you the angle. So let me just find that out for you. So sine 75, take that answer, divide it by 10, take that answer, multiply it by 8, press shift, answer, and you should get 50.6. So m is equal to 50.6 degrees, because you're finding that out. Okay, so that's using the sine rule. Now let's move over. I've got two questions here. We're going to apply the cosine rule. Now how do you know when to apply the cosine rule? Well, like I said before, if you have a match, then you apply the sine rule. If you have no match, that means you're going to have to use the cosine rule. You have to memorize both rules because none of these rules are going to be given to you in the new specification. So let's see how we can do it. Alright, okay, so I've got a squared. Now a squared represents the side I'm trying to work out, and this happens to be h in this example. So instead of writing a squared, I'm going to write h. Now b and c can be either 88 or 146. It doesn't really matter. So let's call b 146. Let's plus 88 squared, and let's minus 2 times by, I would put this in a bracket in my calculator, 2 times by 146 times by 88, close my bracket, put cos, and 53 is the one that corresponds to the h, as you can see. That's why we leave it there, and then we're going to work this out. So you can put this whole entire calculation in your calculator, and then work that out. Plus 88 squared minus 2 amounts of 146 times by 88, close bracket, cos 53. Okay, so we've got a big figure there. That's 13595.76. So let's write that down. So we've got 13595.76. Now just to get h on its own, that means I need to root that answer. Just make sure when you are in the exam that you are writing these steps, because some students just write it straight into the calculator and you will lose marks. Final answer is 116, and that looks about right. So that would be an appropriate length for a triangle with these kind of units. Now we look at this bit. So some students found it confusing. You can memorize the rearrangement of this. I wouldn't advise of it unless you really get a lot of practice and you've got good memory. But if you just remember this, you can still stick to this formula. Again, we inspect, is there a match? Well, there's no angles present, so you definitely need to use the cosine rule. Okay, now this time we're trying to work out the unknown, which is a. We're going to call this a. Okay, so if this is a, then I definitely know a, the small a in this, is 8 squared. I'm going to equate that to 5 squared plus 3 squared and minus 2 amounts of 5 times by 3, which is cos of a. So this is 64 equals to 25 plus 9 minus 30 cos of a. Okay, so 25 plus 9 is 34 minus 30 cos of a, and this is 64, and then we have 64 minus 34, which equals to minus 30 cos of a. So 34 minus 64 minus 34 is 30, equals to minus 30 cos of a. Let's scroll down. There's a bit more room. Okay, so in this part, if you bring minus 30 over to this side, you get 30 over minus 30, which is cos of a. And that will give us 30 divided by minus 30 is minus 1. So that gives us minus 1 equals to cos of a. And to take cos to the other side, you're going to do shift cos. Will give you a, and a equals to, you shift cos, and you put minus 1 in your calculator, you'll get 180 degrees. Okay, so that calculation doesn't seem to work out there. So let's just double check. Could be an error in the question. Okay, so that would be that then.